Hello everybody, today we will be solving problem 5 from the geometry round of the 2018 HMMT February competition. The problem reads, in the quadrilateral MARE inscribed in a unit circle omega, AM is a diameter of omega and E lies on the angle bisector of angle RAM. Given that triangles RAM and REM have the same area, find the area of quadrilateral MARE. Okay, so I started out with a diagram over here, and I've marked these two equal angles. Since E is on the angle bisector of this angle, angle MAE is equal to angle EAR. We can also mark a few other things. We can mark this angle ARM, which since AM is a diameter, this angle is a right angle since right angles subtend 180-degree arcs of a circle, right? We're also given that triangles RAM and REM have the same area. So actually what I'm going to do here is I'm going to drop an altitude from E to side RM, and I'm going to call this point P. Okay, now I'm going to claim a few things. One, that side RE equals side ME. And actually, let me switch to a different color. I'm going to mark the center O for now, and then in order to prove this, I'm going to draw OR, OE, and OM. And since this is a unit circle, all of these are equal to each other. They're all actually equal to 1. We're also given that if this angle is theta and this angle is theta, then arc RE is twice this inscribed arc, so 2 theta, and angle ROE is 2 theta as well. We're also given arc ME is twice this inscribed angle, so arc ME is also 2 theta. So this angle is 2 theta as well, since O is the center, right? And we have a pair of similar triangles, right? Triangle ROE is congruent to triangle MOE, right? Because of side angle side congruence. Therefore, RE is equal to ME as desired. Okay. Now that we have that, let me get rid of all these red marks that will be distracting to the diagram as we keep adding to it later in the problem. Okay, and so we've got that covered. That's going to turn out to be pretty important. So we can mark RE is equal to ME. And now what am I going to do? Okay, since remember we just dropped altitude EP on MR. But now that we know that triangle MER is isosceles, we actually have that MP equals RP. You can use hypotenuse-like congruence to prove this. I'll do it. ME equals RE. EP is equal to itself. And angle MPE is equal to angle RPE. So by HL congruence, triangle MPE is congruent to triangle RPE, and thus MP is equal to RP. Essentially proves this claim as well. So let me mark this down as a pair of equal sides as well. So now we're going to get somewhere. Okay, we're given this information. Triangle RAM and triangle REM have the same area. What does that mean? It means that, well, take a look at triangle RAM area is equal to base times height. RAM is equal to base times height. Since this is a right triangle, this is, well, base times height divided by 2. AR times MR over 2. Triangle REM has area base times height over 2 as well. But since EP is altitude side RM, we give an EP times MR over 2 is equal to this area, and these two are equal to each other. And essentially what this means is that AR is equal to EP, since AR times MR over 2 is equal to EP times MR over 2. So we can mark those down as well, okay? Now what can we do? We can claim another triangle congruence here, and that's going to be if we let this intersection be Q. We have triangle QAR is congruent to triangle QEP, and how are we going to prove that? We're going to use angle side congruence, should I say. We have this angle is equal to this angle. We have this right angle is equal to this right angle, and this side EP is equal to side AR. Angle side similarity gives this congruence. And essentially what that means is that QR is equal to PQ. Right? So we can call QR X. Actually, I'll do it in a different color. We can call QR X. We can call PQ X as well, since we know QR is equal to PQ. But remember, we know MP is equal to RP, which means that MP is 2x since RP was 2x. Right? Okay. So now what can we do? We can apply well, since I'm gonna draw this separately. Triangle RAM, we have an angle bisector, so we can use the angle bisector theorem. That basically says that if you have an angle bisector, and this is A, this is B, this is M, this is N, you have A over M is equal to B over N. In this case, we have AR over X is equal to AM. Well, since AM is the diameter of the unit circle, this AM is equal to 2, and NQ is equal to 3x. So you can multiply both sides by x to get AR is equal to 2 over 3. And Pythagorean theorem gives, nice and easy, RM squared plus AR squared equals AM. You can solve for RM, you get RM equals square root of 2 squared minus 2/3 squared. You eventually get 4 root 2 over 3. Okay, and now let me clear up some space so I can write the final steps of this. We have RM is 4 root 2 over 3, so triangle RAM has area base times height divided by 2. So AR is 2/3 times MR is 4 root 2 over 3 times 1/2. This is equal to 4 root 2 over 9. We want the area of quadrilateral MARE. You can realize that MARE is the sum of triangle RAM plus triangle REM. Since these are the two triangles that make up this quadrilateral essentially, but since the area of triangle REM is the area of triangle RAM, you're going to end up with, this is 2 times the area of triangle RAM, which is 2 times 4 root 2 over 9, which gives you a final answer of 8 root 2 over 9. So thanks for watching, and I will see you next time.